Somewhere above restricted airspace, an aircraft is quietly changing the rules of modern warfare. It doesn't appear on radar screens or leave a clear heat signature behind. Instead, it moves through the sky almost unnoticed. That aircraft is the B-21 Raider, the U.S. Air Force's next-generation stealth bomber built by Northrop Grumman. Unlike earlier stealth aircraft that focused mainly on radar evasion, the B-21 was designed for a battlefield filled with satellites, infrared sensors, and advanced detection systems. In a world where tracking technology keeps improving, the Raider represents a new generation of stealth, one built to survive and operate in the most advanced surveillance environment ever created. The growing threat from space. For years, military planners believed stealth aircraft like the B-2 Spirit and F-22 Raptor would dominate the skies by avoiding radar detection. But a new challenge has emerged from space. Thousands of satellites now orbit Earth, many capable of capturing high-resolution images and tracking activity across vast areas. In 2024, Chinese researchers demonstrated this capability when the Jilin-1 satellite constellation photographed an F-22 flying through cloud cover. Unlike radar systems, satellites use optical and infrared sensors that simply observe what is visible from above, meaning traditional radar-absorbing materials provide little protection. This raised a serious question for military engineers. How can an aircraft remain hidden not only from ground radar, but also from satellites in orbit? The B-21 Raider was designed to solve that problem. All-spectrum stealth. Traditional stealth aircraft were optimized primarily to defeat radar. The Raider takes a much broader approach. Engineers describe the B-21's design philosophy as all-spectrum stealth. Instead of focusing on a single detection method, the aircraft is engineered to reduce its visibility across multiple types of sensors simultaneously. Modern detection networks rely on a combination of technologies: radar systems that track objects using radio waves, infrared sensors that detect heat signatures, optical cameras capable of spotting aircraft visually, electronic intelligence systems that monitor communications and emissions. The B-21 is designed to minimize its presence across all of these detection methods at the same time. Achieving this required rethinking almost every aspect of aircraft design. The shape of invisibility. At first glance, the B-21's appearance resembles the earlier B-2 Spirit. Both aircraft use a flying wing configuration, which eliminates vertical stabilizers and other protruding surfaces that could reflect radar signals. However, the Raider's shape is far more refined. Every curve and angle of the aircraft is carefully engineered to scatter radar waves away from their source rather than reflecting them back toward radar receivers. Smooth, continuous surfaces reduce the number of edges where signals could bounce back. The aircraft's engine intakes are also deeply recessed within the airframe. This prevents radar from reflecting off the turbine blades inside the engines, a common source of radar returns on conventional aircraft. These subtle design changes significantly reduce the Raider's radar cross-section, making it extremely difficult for radar systems to track the aircraft consistently. But radar is only one part of the stealth equation. Advanced radar-absorbing materials. The outer surface of the B-21 is covered in sophisticated radar-absorbing materials, often referred to as RAM coatings. These materials absorb incoming radar energy rather than reflecting it back toward the radar transmitter. The result is a drastically reduced radar signature. Earlier stealth aircraft, such as the B-2, required extensive maintenance to keep these coatings effective. The delicate materials could degrade under stress, requiring constant repair. The B-21 introduces a new generation of radar-absorbing treatments designed to be far more durable. These materials can withstand extreme temperatures, high-speed flight, and environmental exposure while maintaining their stealth characteristics. This improvement not only enhances the aircraft's survivability, but also reduces maintenance costs and downtime. Managing heat. One of the biggest problems for stealth aircraft is heat. Jet engines produce enormous amounts of thermal energy, and infrared sensors are specifically designed to detect that heat. Modern missiles often rely on infrared tracking systems to lock onto targets. To reduce this vulnerability, the B-21 incorporates several methods of thermal management. First, the aircraft's engines are buried deep within the airframe, making them difficult to observe directly from outside the aircraft. Second, the exhaust system is engineered to cool hot gases before they exit the aircraft. This helps reduce the infrared signature that enemy sensors might detect. Some analysts believe the Raider may even be capable of dynamically adjusting its surface temperature to blend with the surrounding atmosphere at high altitude. If accurate, this capability would make it significantly harder for infrared sensors to distinguish the aircraft from the sky. Such technology would represent a major advancement in stealth engineering. Hiding from cameras in space. Perhaps the most fascinating challenge facing the B-21 was the problem of optical detection from satellites. Unlike radar or infrared systems, cameras simply capture images of what they see. No amount of radar-absorbing paint can prevent a camera from spotting a large aircraft against the sky. To address this problem, engineers approached the issue from several angles. The Raider's blended design reduces shadows and reflections that might make the aircraft stand out visually. Special coatings help minimize contrast between the aircraft and the surrounding sky. Mission planning also plays an important role. Satellites follow predictable orbital paths, meaning their positions can be calculated in advance. By analyzing satellite movements, mission planners can schedule flight paths that minimize exposure to overhead observation. Additionally, the B-21 can operate at extremely high altitudes, where atmospheric conditions such as haze, cloud cover, or darkness can help conceal the aircraft. Instead of relying on complete invisibility, the strategy focuses on making the aircraft difficult enough to detect that by the time someone notices it, the mission is already complete. A digital bomber. Beyond its stealth capabilities, the B-21 Raider is also designed as a highly digital aircraft. Older bombers such as the B-52 and B-1 were originally built using largely analog systems. Over time, modern electronics were added, but these upgrades often required expensive modifications. The Raider was designed from the beginning as a digital platform. Its advanced avionics combine data from multiple sensors, radar, electronic warfare systems, communications networks, and infrared sensors into a single integrated display for the pilots. This process, known as sensor fusion, provides a clearer picture of the battlefield. The aircraft also features an open architecture design, meaning its software and hardware can be upgraded more easily as new technologies become available. This ensures the bomber can adapt to evolving threats without requiring a complete redesign. A flying command center. The B-21 is more than just a bomber. Military planners envision it operating as a central node in a larger network of systems. The aircraft may be capable of controlling unmanned drones, often referred to as collaborative combat aircraft. These drones could fly ahead of the bomber to jam enemy radars, gather intelligence, or act as decoys that confuse air defense networks. Meanwhile, the B-21 would coordinate the operation while remaining hidden from enemy sensors. This concept transforms the bomber into something closer to a flying command center, capable of managing complex operations across multiple domains. Range, weapons, and flexibility. Operationally, the Raider is expected to have an impressive range. The aircraft can travel more than 6,000 miles without refueling, and aerial refueling allows it to operate across nearly unlimited distances. This gives the United States the ability to project power globally. The B-21 is designed to carry both conventional and nuclear weapons, including precision-guided bombs, long-range cruise missiles, and potentially future hypersonic weapons. Its internal weapons bays are modular, allowing the aircraft to be configured for different mission types depending on the requirements. One day it may perform nuclear deterrence missions. The next, it might conduct precision strikes against critical military targets. Production and deployment. The B-21 Raider program has progressed steadily in recent years. Flight testing began in the mid-2020s at Edwards Air Force Base in California, and multiple test aircraft are currently undergoing evaluation. The U.S. Air Force plans to acquire at least 100 Raiders, though the final number could increase depending on operational needs and budget considerations. Each aircraft is estimated to cost around $700 million, which is significantly less than the $2 billion price tag associated with the earlier B-2 Spirit. The first operational B-21s are expected to be based at Ellsworth Air Force Base in South Dakota, with initial operational capability targeted for the late 2020s. Why the Raider matters. Countries like China and Russia have spent decades developing sophisticated air defense systems designed to keep enemy aircraft away from their territory. Advanced missile systems, long-range radars, and integrated defense networks form layers of protection intended to stop incoming threats. The B-21 Raider is specifically designed to overcome those defenses. By combining advanced stealth, electronic warfare capabilities, long-range, and networked operations, the aircraft can penetrate heavily defended regions and strike strategic targets deep inside enemy territory. This capability plays a critical role in deterrence, the idea that potential adversaries may think twice about aggression if they know their defenses cannot guarantee protection. If you enjoyed this breakdown of the B-21 Raider, make sure to like and subscribe for more deep dives into military technology and aviation. Thanks for watching.